Welcome back to geometry in the last section for chapter 11. We put two concepts together here that at first seem pretty strange. The two concepts being geometric measure, and in particular we're going to be talking about area. So the geometric part of this is going to be area. And then the other idea that we put together here is probability. Now you guys have talked about probability before with things like rolling dice or flipping a coin or that sort of thing. But we're then going to put probability together with geometry. Okay? And what we're going to do is we're going to be taking geometric shapes and we're going to be randomly selecting one of the points. So think about any shape. We're going to be randomly selecting some point within that shape. And what we're going to assume or pretend is that every point is equally likely to be selected. And then what we're going to ask you to do is calculate the probability of picking a point within some sort of shaded region. And the formula I'm going to need everybody to write down is here at the bottom of the screen. The probability of picking a point in a shaded region is equal to the shaded area divided by the total area. So that's just simply our formula that we're going to work with in this section, that the probability of randomly selecting a point in a shaded region is equal to the shaded area divided by the total area. So you can see we're going to be calculating areas for a shaded region and then for a total region. So we're going to be calculating two areas. That's the geometry part. And then when we divide, that's what creates the probability. Okay? So let's do a couple of examples. You'll find that it's fairly simple. As an example here, what's the probability that we pick a point in the green shaded region? All right? What's the probability of picking a point in the green shaded region? So any point within the big rectangle is equally likely to be selected. So it's equally likely to select that point or this 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 point. Any of those points are equally likely to occur. So if we randomly select a point, what's the probability that the point falls in one of the green regions? Okay, well the formula is that we calculate the area of the shaded region and divide by the area of the total. Okay, so in this shape, what's the total area going to be? Well, it's going to be the area of a rectangle, and I think you guys can see clearly from the picture that the length of the rectangle is 14 and the width of the rectangle is 6. But what's a little bit harder then is to calculate the area of the shaded region. How much area is shaded in green? How much area is shaded in green? Well, it'd be the area of the whole rectangle. So let me write that kind of above here. It'd be the area of the rectangle, which we know is 14 times 6. Oops, sorry about that. Is 14 times 6. But then what we've got to do is subtract away the area of the circle. And the area of a circle is going to be pi times the radius squared. So we take the area for the whole rectangle and then subtract away the area of the circle. So if I subtract away the area of the circle, if I take away the area of the circle, everything that's left then is green. All right, and that's just simply all we have to do is this arithmetic. So 14 times 6 is 84. Pi times 2 squared, let's see, whoop, I hit the wrong button there. Pi times 2 squared is 12.6. Again, 14 times 6 is 84. And sorry, I'm a little short on room there, so I'll just finish off over to the side. 84 minus 12.6 is 71.4. And 71.4 divided by 84 is 0.85. So the probability of selecting a point in the green shaded region would be 0.85. And for those of you guys who remember your probability from the last couple of years, remember probability runs on a scale from 0 to 1. And so a probability of 0.85, would be tucked in right about here somewhere, is fairly high. It's fairly likely that you're going to be picking a point within the green shaded region. Okay? All right, so let's just try a couple more of those. This one I had kind of a tough time drawing, so I'm going to have to give you the problem specifically here. What's the probability of picking a point in the light green? I know it doesn't look as good as the previous problem, but what's the probability of picking a point in the light green? Well, the formula says geometric probability is going to be the probability of the shaded region, so the probability, the area of the light green divided by the total area. Now, usually the total is the easier one to find. Usually the denominator is the easier one to find. What's the big shape here? What's the biggest shape? It's a trapezoid. So the area of a trapezoid, relatively easy to find because you have a formula from earlier in the chapter, is going to be base 1 plus base 2 times the height divided by 2. So it's going to be 12 plus 18. So let me choose my laser pointer. So one base is 12. The other base is 18. So we add the two bases together. And then we multiply by the height in between the two bases, 5, and then divide by 2. And I'll get my calculator out and do that computation in just a minute. But then the other one we need is the numerator, which is the area of the shaded region. So how do we calculate the area of the light green region? Well, we have to start by taking the area of the trapezoid, which is 12 plus 18 times 5 divided by 2. So that's the area of the trapezoid. And what we have to do is remove the area for the rectangle. And you can see clearly from the picture the dimensions of the rectangle are 9 and 3. Okay? And after that, it's just a matter of computation. 12 plus 18 is 30. 30 times 5 is 150, and 150 divided by 2 is 75. 9 times 3 is 27. 75 minus 27, I'm going to double check that one. I think that's 48. Yep, that's 48. And then I'm just a little short on room. When I punch that division out, 48 divided by 75 is 0.64. So the probability of selecting a point in the light green region, so picking a point here or here or here or here or here or here or here, is 0.64. Remembering, probability runs on a scale from 0 to 1, so 0.64 is going to be right in about there somewhere. Okay, and I've got one more of these to do. All right, I've given you guys a problem involving a couple circles, and I'm going to ask you for the probability of selecting a point in the green region. This one turned out a little bit nicer, a little bit brighter, so I hope you can see it okay. So again, the formula says take the area of the green shaded region and then divide by the total area. The total, again, is relatively easy. That's just going to be the area of the bigger circle. So that's going to be pi times 7 squared. The area of the green, though, in the numerator is a little bit tougher because we have to start with the whole circle and then subtract away this smaller circle. This smaller circle is not green, it's white, so we have to subtract that away. And so what we do is we then have to subtract away the area for that smaller circle, which would be pi times 2 squared. Okay? And so what we end up with on this one, guys, is 49 pi minus 4 pi divided by 49 pi. And I'm intentionally not multiplying out the pi's right now because I just want to show you how nicely this works. 49 pi's minus 4 pi's is 45 pi's. And then we have a pi in the top, pi in the bottom, so that would cancel. So we just get 45 over 49. We'll usually punch that out as a decimal, though, which we could have done at any time, I know, but I just chose to do it at the end. So the probability of selecting a point in the bright green here would be 0.92. So again, probability running on a scale from 0 to 1, 0.92 is going to be awfully close, awfully high, awfully close to 1. Okay, so those are just the two concepts that we put together here in section 7. I hope you find them to be a fairly easy one. It's just going to be a matter of how do I calculate the area of a blue. I think most of the problems they use blue in your textbook. What's probability of selecting a point in the blue regions? Okay? Alrighty, so go ahead and pause or stop this video and then take a look at your assignment and see how you can do. Alright, hope you're having a good day.